Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So in this particular tutorial, we're going to look at on how to read from the pure substance tables. In this particular case, we're going to look into these questions, which is for R134A. Actually, you can see the answer here. Just that from this tutorial, we're going to look on how to get the answer from the table. Okay, so without further ado, we'll start with the first one, the first row here. Take note that in this particular example, they're given 4 properties, that is the temperature, pressure, specific volume, and phase description. There will be another example that we're going to discuss, that is they will give us the enthalpy value. So since that for this example there's no concern for the X factor, just so that we take note on that. Alright, for the first row, it is given the temperature and pressure. So from here we can look let's have a look at the temperature, which is minus 8 degrees C. So if you look here at table 11 for temperature, saturation, pressure table, minus 8 is located here, whereas the pressure given here is 220 kilopascal, whereas here the saturation pressure is lower than the given pressure. So what does it mean? It means that if the saturation pressure is lower than the given pressure, it means that it is located in the compressed liquid region. Why, you might say? This point given here, minus 8, 217 kilopascal, is actually located at exactly at this point, right? So since that the pressure is higher, so means that it might be referencing to a higher saturation pressure, like that. So maybe, but since that it's meant minus 8, so it might coincide with that line. So the location of that line is located over here instead. So when that happens, we've discussed this in our lecture before. For compressed liquid region on the left side, the properties actually refer to the corresponding saturated liquid line. So in this example, even though the pressure is much higher and it's located inside the compressed liquid region, but to get the value for the specific volume, we refer to the at this point, which is the saturated liquid line at minus 8 degrees C, or 217 pressure. Alright, 217 kilopascal. So in this case, the volume is this one, saturated liquid specific volume, which is 0.000751. A little bit different from the answer. I'm not sure why, but actually only different by 2 points. Only different by 2 points, right? And of course, it is located in the compressed liquid region. It is located in the compressed liquid region. And next, let's have a look at the second row. Here it's given 30 degrees C and the specific volume is 0.015. So in this case, we refer to 30 degree C, and we look at the saturated liquid VF and saturated vapor VG, right? So here it's given that 8421, 26622. And if you look into the given specific volume, we know that it is located somewhere in between VF and VG, right? Maybe somewhere at this point. So it tells us it's located in the saturated liquid vapor region. And so for that, to the value definitely for the pressure is this one, 770.64, because we know that it is located in between, and the phase description is saturated liquid vapor region, like this one. So here you can refer that the answer is 0.015. Pressure is 770.64, at 30 degrees C, and the region is located as saturated, liquid, and vapor region. Okay, right. Next is the third row. It is given the pressure and the phase description is exactly at the saturated vapor line. So with that, it makes our job much easier. We just simply refer to the corresponding pressure, 180 kilopascal, and refer to the saturated vapor line, because the phase description is the saturated vapor line. So this is the corresponding temperature. So here the temperature is minus 12.733, 12.73 minus 12.73, and the saturated vapor specific volume is 0.11041. It's 0.11041. It's exactly as that. Right. So for the fourth row, we'll do it in the next slide. Okay. For the fourth row, right here, we given temperature and pressure, but this time around, as opposed to the previous example, at 80 degrees C, right? At 80 degree or at 600 kilopascal, which is this one, the saturation pressure, the saturation temperature for 0.6 megapascal or 600 kilopascal is 21.55 degrees C. So it means that the temperature is much higher than that. Okay. So here, for example, let's say this line is 0.6 megapascal. Right. This is 0.6 megapascal, and the temperature here is 21.55 degrees C. But our temperature is way higher. So if it's way higher, that means it is somewhere here in the superheated vapor region. So with that, so we know that it is located here. So we turn to table A-13, which is for superheated refrigerant R134A, and then you go to this side. We know it's on the 0.6 megapascal, and the corresponding temperature is 80. So you just make a line like that, and then here we are looking for the specific volume. So the specific volume is given as so, and we know that it is located in the superheated vapor region. So that for that table, we know it's 0.04471 for the specific volume, and it is located in the superheated vapor region. So there you have it. Hopefully that helps. I'll see you in a future video. Thank you all.